Our planet is warming. This is not a drill, it is happening now. The Earth's temperature has been steadily increasing and the consequences are becoming clearer each day. Glaciers are melting at alarming rates, sea levels are rising and extreme weather events are becoming more frequent and intense. The primary culprit behind this global warming is the increase in greenhouse gases in the atmosphere. These gases, mainly carbon dioxide from burning fossil fuels, trap heat from the sun, much like a blanket wrapped around the Earth. As we continue to burn fossil fuels for energy, transportation, and industry, we release more and more of these heat-trapping gases. The more greenhouse gases we emit, the warmer the planet gets, leading to a cascade of effects on our climate. This phenomenon is what we call climate change, and it is one of the most pressing challenges facing humanity today. The impacts of climate change are far-reaching, affecting everything from our food and water security to our health and well-being. Faced with the daunting reality of climate change, scientists and policymakers are exploring various solutions. While reducing greenhouse gas emissions is crucial, some are turning to a more radical approach: geoengineering. Geoengineering encompasses a range of large-scale technological interventions aimed at counteracting climate change. It is essentially an attempt to engineer our way out of the climate crisis by manipulating the Earth's natural systems. There are two main categories of geoengineering: carbon capture and solar radiation management. While both aim to mitigate climate change, they operate through different mechanisms and carry distinct risks and benefits. The idea of intentionally altering the Earth's systems on such a grand scale might seem like science fiction. However, as the urgency of climate change grows, geoengineering is garnering increasing attention as a potential tool in our fight against global warming. Imagine giant vacuum cleaners sucking carbon dioxide directly from the air. While this may sound futuristic, it is the basic premise behind carbon capture, one of the two main branches of geoengineering. Carbon capture technologies aim to remove carbon dioxide from the atmosphere and store it safely, preventing it from contributing to further warming. This could involve capturing emissions directly from power plants or industrial sources, or drawing down existing carbon dioxide from the air. One example of carbon capture is afforestation, or planting trees on a large scale. Trees absorb carbon dioxide during photosynthesis, acting as natural carbon sinks. Another approach involves using machines to capture carbon dioxide from the air and store it underground in geological formations. While carbon capture holds promise, it also presents challenges. The technology is still under development and can be expensive to implement on a large scale. Storage of captured carbon also raises concerns about potential leaks, which could negate the benefits. Despite these challenges, carbon capture remains a viable option in our fight against climate change, offering a way to address our past emissions and mitigate future warming. Section 4. Solar radiation management reflecting the sun's heat. The second major category of geoengineering, solar radiation management, takes a different approach. Instead of removing carbon dioxide, it aims to reflect a small portion of sunlight away from the Earth, reducing the amount of heat trapped by greenhouse gases. One proposed method involves injecting tiny reflective particles into the stratosphere, mimicking the cooling effect of volcanic eruptions. Another strategy involves brightening marine clouds by spraying seawater into the air, increasing their reflectivity. Solar radiation management techniques offer the potential for rapid cooling, potentially offsetting some of the warming caused by greenhouse gases. However, they also carry significant risks and uncertainties. Tampering with the Earth's delicate climate system on such a large scale could have unintended and potentially catastrophic consequences. For instance, altering precipitation patterns could disrupt agricultural systems and water resources. Furthermore, solar radiation management does not address the root cause of climate change: greenhouse gas emissions. If these emissions continue unabated, we would be relying on a technological fix with potentially dangerous side effects. Section 5. A cautious approach to a global challenge. Geoengineering presents both a tantalizing promise and a daunting dilemma. On the one hand, it offers the potential to mitigate the worst effects of climate change, buying us precious time to transition to a low-carbon future. On the other hand, these technologies are still in their infancy, and their large-scale deployment carries significant risks and uncertainties. The potential consequences of tampering with the Earth's complex systems are vast and unpredictable. Therefore, any consideration of geoengineering must be approached with extreme caution. Thorough research, ethical considerations, and international cooperation are crucial to ensure responsible development and deployment. Ultimately, geoengineering should not be seen as a silver bullet solution to climate change. It is essential to remember that the most effective and sustainable solution lies in addressing the root cause of the problem, reducing our greenhouse gas emissions. Geoengineering, if pursued at all, should be viewed as a complementary strategy, a temporary measure to buy us time while we work towards a more sustainable future. Our planet's fate depends on our choices today.